Welcome everyone to our webinar today, and I'm together with my colleague Radu.
Hi everybody, my name is Radu. I'm very happy to be here.
We hope we'll show you some interesting ideas and that you may be able to use them further. So our affiliation is Oxygen XML editor. And Syncrosoft. Syncrosoft is the company, and Oxygen is our main product. We both have a large number of years experience with XML and DITA. Especially Radu got involved more than me with DITA. And let's see what will an overview of our today's presentation. First, I will try to describe the idea behind DITA class. Then Radu will cover the implementation together with a number of examples. And at the end, we'll have a Q&A section preceded by a few conclusions of our talk. Also, as Lavonia mentioned, feel free to ask questions also during the presentation, because Radu and me will be able to answer them as we go, and we will also come back to them at the end. But it's also always better to ask the question when you feel there is something to ask. So let me start talking first about structure from structured content. And basically, I think that in today's world, we need to react fast to different needs. And this need for speed, in our case, when we deal with information, basically means need for structure. We need to have our information in a structured form. And the structure is important, and I mean basically at a logical level, not necessarily the actual form of encoding that structure. So we can have that structure encoded maybe in different forms, but what's really important is that structure, and more clearly having a consistent structure, because a consistent structure implies automatic processing. So we are able to write algorithms to process that structure. And if the structure is consistent, then we do not have a lot of variation. So we can cover that more easily in an algorithm. Of course, if we have a consistent structure, then we can convert from one form of encoding to another. That's why basically the actual encoding of that structure is not that important, but consistent structure is what is really, really important. And we have structured content in different forms. For many of us, structured content probably means DITA or XML. But if we look within an organization, we may find structured content in also in other forms. They may be more or less consistent, but we can have, HTML files, MarkDown, Excel or other spreadsheets, comma-separated values or tab-separated values, and so on. Then we can have programming files like source files for C or Java and so on. But these forms of structured content cannot move to DITA overnight, or cannot move to DITA at all. If you look, for instance, at API documentation, that is usually written within a source file, and all the tools that help developers, know what a field represents or what a method should be called for, and so on, use that format, which is within the source file itself. So we cannot expect, if we want to use or create DITA-based documentation, API documentation, we cannot expect, all developers to switch to DITA for that, and then all the tools that IDEs and so on to support DITA as a format for that API documentation. So sometimes it is impossible to try to unify the entire content on a single model. So now if we look at DITA, DITA is encoded as XML documents. And recently there is also the Lightweight DITA initiative, which is basically a profile of DITA aimed for as a starting point to to be easier for people to start with DITA. But an interesting part with lightweight DITA is that Michael Priestley presented also other forms of encoding lightweight DITA. So he presented a convention for encoding lightweight DITA in HTML, and I think I've seen also a MarkDown variant of that. But anyway, we can imagine different forms of encoding the structure that is specified by the lightweight DITA specification, or maybe by a DITA specification. So now if if we look at this real example where lightweight DITA has a convention that says, well, if you want to serialize a lightweight DITA in HTML, here are the tags that you need to use in HTML for for the title, for the abstract, and so on. Here's the structure that you need to use to encode lightweight DITA in HTML. So just imagine that we think the other way around. If we look to an HTML file, we can think, well, this is an encoded DITA topic as HTML. If we look at an Excel file, we may think, well, this is a way to serialize, to save a DITA topic that contains a table, right? So if we have a DITA topic containing a table, we can encode that as an Excel file. Or if you look at the Java source file, you may think, well, this file is actually a way to save a DITA topic that describes a class, the methods, the fields, and comments, information about that Java class. And that DITA topic is actually saved on disk or serialized or encoded as that Java source file. So if we look at this and we think, well, these are different ways to encode DITA topics, then we need to think also, okay, we need to get back maybe to DITA, to the standard or normalized or let's say to the standard way of specifying DITA as XML, let's say. So why we'll need to get back to DITA XML? Because our processing workflows are based on that format. that, let's say, the normative format. So in order to use, for instance, the Data Open Toolkit to process and publish the content, we need to have Data XML. And then the question is how? How can we get back to Data XML from all these different formats that in our imagination, in our mind, encode data topics? So basically they are virtual data topics. And the idea behind Data Glass to get, for instance, an Excel file back into the data world is to use URLs. So to use a URL that will point to the Excel file and will retrieve, will show that as a data topic. So basically, if you have, a reference to a topic in data, we can have a URL that, let's say, it has this form like Excel to data column slash, and then this points to a URL that identifies the Excel file. So basically, if we look at this Excel file identified by this URL, through this URL which says Excel to data and then points to the other URL, we will see a data topic. So URLs are the way you access information usually on the web, but not only on the web. URL stands for Universal Resource Locator, and any document can be referred as a URL or through a URL. URLs encode information, not only a location for a document, but for instance, if we look at an HTTP URL, this part is the URL scheme or the protocol. Then we may have different credentials to access that resource. Then we may have a server location, a path to a resource, and if that resource is a script, then we may have some parameters that specify to that script how to process the information that should be retrieved. So a URL encodes not only location information but also processing. Again, if we want to refer to a topic in data, we say topic ref format equals data href equals, and then we have a URL, which may be a local file, which may be an HTTP URL, an HTTP secured URL, which implies encoding and decoding as additional processing. It may be a zip URL, which will look within an archive. So this will, this type of URL basically will has the URL to the archive and then a path to that file within the archive. So this will extract the file.data from within that archive and will retrieve that content. And why not, in our case, if we want to see an Excel file as data, we can use a protocol like Excel to data column slash and then point to that Excel file. Now this idea is not limited to get content look as data. We can use the same idea to see content as dogbook or TI or XHTML, or see content as an SVG image, and Radu will have an example of that. later on. If we have time at the end, I can also show you a way in which we see a style guide as a schematron schema, so basically enforcing rules written directly in the style guide. Or we can process other resources like Excel or MarkDown and so on with XSLT and XQuery or XProc, languages that are usually are designed or are developed to process XML documents and so on. This will enable us to be able to publish across different formats using DITA tools, and we can either use content in other formats as entire documents, so we can just refer with the topic ref to that content, and we'll have that as a virtual topic in our DITA map, or we can refer to that topic and mark that as a resource only topic, so it's not directly part of the published result. And then from within other topics, we can use the conref mechanism from DITA and bring in parts of that document. So, for instance, you may get only a line with the total values from a spreadsheet and so on. Or in case of a Java source file, you may bring in the syntax definition of a specific method, not the entire Java class. So that's mainly the idea behind DITA class, to use URLs pointing to a different type of resource, to bring that within the DITA world, to see that as a DITA topic. And then from that on, we can use that as if it was a DITA file, a real DITA file. And now I will give control to Radu, so he can show more on the implementation part and examples of different conversions that can be done. Radu?
Yes, George, right away. Okay, so I will make myself the presenter now. And here we go. So George has had this excellent idea of seeing content as something else. And we wanted to implement this as a very flexible pipeline architecture in which you can visualize the original content flowing through the right side and the converted content flowing and outputting from the pipe on the left side. So a pipeline would have modules which will be connected one to the other, and each module will be capable to obtain some content and to convert it to something else. For example, to obtain Excel and to convert it to XML, or to obtain an XML and convert it to DITA, and so on. So this is a very simple architecture. A converter can only go one way, so it only knows to take content from one side and to pass it on the other. And here's what an URL with such converters looks like. First, you have a reference to the target, which in our case is the original content which needs to be converted. And then you have steps in the URL. Each steps induces a transformation in the content, and the content changes as it flows through each step. And on the left part, you get the converted content. This content is not located, this converted content is not located anywhere on disk. So this is not the kind of conversion in which you give an output folder and you say, okay, take the original content and make data from it, save it here. This is a pipeline through which the original content is seen as converted. It's like a looking glass, a magic glass to which you look in the pipeline and you see data, although the original content was Excel or something else. A processor or a module in the pipeline is very simple and it only goes one way. But we also conceived the possibility that somebody might want to edit the converted format and then save it to the original. So we also conceived a way in which these URLs could have pipelines which go the other way, through which they could edit the content in Oxygen, for example, save it, and then have the content automatically be modified and converted to the original file format. We implemented only 6 processors. One of the processors we implemented is Excel to XML. So it's a simple processor which takes Excel and outputs a custom XML format, which is not DITA. We have another processor which takes JSON and outputs XML. A processor which takes not well-formed HTML content, maybe from the web, maybe from an online editor, and makes it XHTML. This is useful because after this conversion we can apply other converters which can take the XHTML and apply some XML style processing on it. The fourth converter is the XSLT XQuery converter. This converter takes the original format and it also takes a style sheet or an SQL script specified in the URL and converts the original content with that style sheet by applying the style sheet, and the result is the output coming from this converter to another stage. The JavaScript converter takes the original content and calls a JavaScript library somewhere on your local disk, for example, and it calls a method from that, and that method can change the content and the converter can give you the modified content. And the Java converter again takes the original content, calls a JavaScript method from a Java library, for example, which processes the content and returns another format of content derived from the original one. So the first 3 processors are fixed, they only do one thing, and the third and fourth and fifth processors, they are dynamic. They call scripts which perform various changes on the format. And here is how such an URL syntax looks like. So the URL syntax should be read from right to left. First, it points to a resource. In this case, it's an Excel resource located somewhere on disk. And then applies a processor to it. In this case, it applies the Excel processor. And this is the name of the sheet which will be used which will be converted to the XML. And then after the Excel processor has converted to XML, we have the XSLT processor, which takes that content and applies the style sheet to it. And this is the protocol of the specific convert URL. This is an URL which can become quite hard to manually write by a technical writer, for example. So we use the support given by the XML catalog standard to rewrite certain parts of the URL as a more readable, as a more human readable representation. For example, I can define an alias in the XML catalog and say that this alias, Excel to data protocol, will be resolved to this larger convert URL protocol. And again, I can write an alias and say where on disk my resources are located. And the final URL, which needs to be written by the technical writer, would look like this. It would have Excel to data, and it will point to the Excel document. And it would get passed to the XML catalog, and the application would actually work with this larger URL. But from the end user perspective, you would just use the smaller URL format. There are a lot of third-party formats which would be interesting to merge in an existing DITA application. For example, you may get plain HTML format for an online web editor, or from somebody who can only edit and save HTML. You may get custom XML from another pipeline in your process, in your publication. Maybe you have developers who are very comfortable writing MarkDown, so they write the documentation in MarkDown, but then you have to publish to DITA. Maybe you have an Excel spreadsheet which has certain tables, certain computations, and you need to create a DITA topic from that. And you do not want to use copy-paste, because if you do, you end up with two sources for the same information, and then maybe you forget to change that topic to update it when the Excel spreadsheet changes. Maybe you obtain comma-separated values. This is a format which is an export from a database, from an SQL database. Maybe you have, as George said, Java code which already has documentation embedded inside it, and you want to make some of that documentation available in your larger DITA application. And we'll just go through. I have maybe 6 examples, and we'll go through each other. The first example is Excel to DITA, and it starts like this. I have an Excel spreadsheet somewhere, and the spreadsheet has a table with certain information about various parts, and I want to look at that spreadsheet and visualize it as a DITA topic and include it in my larger DITA map in order to publish the content from the spreadsheet and obtain, for example, HTML from that. And here is my spreadsheet. It has 4 columns. We have a column with part names, which are car parts, wheel, door, engine, tire, descriptions for each part. And then we have columns in which we specified how many parts have been sold in one quarter for each of these parts. So we have the first quarter and the second quarter, and right here we have the total, and the total is based on an Excel mathematical formula. So we have the total for the first quarter and the total for the second quarter. And here we have our examples DITA map. And the first reference in our examples DITA map is to that Excel spreadsheet that I showed you earlier. And again, if you take this protocol and pass it through the XML catalog file, you will see that it actually gets expanded to a larger URL string. But as a technical writer, you can write only the simplified part of the protocol and have it magically resolved. So the first topic reference, if I take it and open it in the application, Although there is a data file on disk, in the application I get a data topic. So this is the data topic equivalent and obtained dynamically from the Excel spreadsheet. It has the 4 columns, it has the total which sums each column. This is read-only, so it is a view of the Excel spreadsheet. And this is the source for the same file. So I have my data topic, which was automatically created with a table. And if I go in the Excel spreadsheet and I make changes and save, you see that the total changed. And then I can go to the source, and the source, the converted data topic has also changed, and the total has also changed. So this is one of the benefits. You let the Excel perform computations, and the topic that you obtain has the most recent content available. Looking at the published output for this, this is how the HTML obtained from the data topic looks like when publishing in Oxygen XML web help format. So with one source, we obtained a data topic. We made that data topic available in a larger publication, and then the publication can be converted to various output formats like PDF or HTML and so on. Again, you can either include this as a regular topic, or in one of your existing data topics, you can make a content reference to the table. Because as you see, the table that was created has an ID. So instead of using this topic as a standalone data topic, you can have another data topic which makes a content reference to the table and only uses this part of the Excel spreadsheet. So Excel to data had 2 stages. We passed Excel to XML using the Excel converter I described in a past slide, and then we passed the XML to data using the XSLT converter, which took an XSLT style sheet, which is quite easy to write. The style sheet is named Excel to data. And again, I've already discussed the benefits. You can dynamically create data tables from spreadsheet. You can allow the Excel spreadsheet to perform computations of various columns. And of course, single sourcing. The content of the table is in one place. It's in the Excel spreadsheet. It was not copy-pasted into another equivalent data topic which would have contained the same information in a redundant form. The second example is HTML to data. You may get HTML because it's quite common format from various places, and you may want to include it as a data topic in your publication. And the HTML to data has two stages. First, we want to take the HTML and make it well-formed XHTML, and we do this with the XHTML converter. And once we have XHTML, we have lots more flexibility, and we apply an XSLT spreadsheet, which with a style sheet called XSLT style sheet, the style sheet being named HTML to data, and the style sheet produces the topic at the end. Just to show you the example, so this is the original HTML file. The HTML file has validation problems, so it's by no means a well-formed XHTML document, but it also contains information that you would like to have in your data topic. And the data map points using this protocol, HTML to data, to the original HTML document. This protocol is resolved in the catalog to this convert pipeline that I described previously. And when I open in the application this topic, I obtain the equivalent data topic, which is valid and can be used in your publication, either as a standalone topic or in another data topic. You can make content references to this to elements with IDs defined in this converted topic. Again, the converted topic is read-only. I have no write capabilities in it because this pipeline goes only one way. But if I change the title of the original HTML document, I go back and this reflects on the spot. This topic is not anywhere on disk, it's just a way through which we look at the HTML content. And the published output, again, I took my data map, I published it to Web Help, and this is the result. So coming back to the benefits, there are so many tools which can produce HTML, and you can gather the content from them without the need to copy-paste it to data topics and to have perfect single source content. A single source from which we publish our content without all the disadvantages of copy-paste editing. The third example is about MarkDown to data. You may have developers which are very proficient in using MarkDown, and they may write documentation about API and about the tools that they build in MarkDown. And you may consider incorporating this documentation in your data project without copy-pasting, without duplicating content. MarkDown to data goes through 3 stages. First, we take the Markdown, and this magic URL creates an HTML version of the Markdown file. And this is done by applying a JavaScript converter with a JavaScript library. There are so many libraries which are available online for free, which can take Markdown and produce HTML from it. And this is one library I downloaded and just call the method from it, and the Markdown is converted to HTML. So this is the first step. Then we take the HTML and we make XHTML from it, the second step. And then we apply the same HTML to data style sheet, which results in a data topic. So I will open my Markdown document, and it looks like this. So let's say I have a developer who has written this Markdown example. We have some paragraph, we have some list items, we have some italic, bold, and monospace items. And the data map points to the MarkDown document, like it would point to a regular data topic, but it passes it through the MarkDown to data converter, which again is an alias for this larger convert URL that is also explained on the slide. So if I open this MarkDown document in the application, I get the data topic. It looks exactly the same, but it's data. You can take it and use it as it is in a publication. Of course, if you want, you can also save it as a data topic, but you use the flexibility of being able to have only one source for that specific information. Again, read-only, but I can modify my article, and then I can go back, and the changes are reflected on the spot because the information resides in only one place. Looking at how the output looks like, so this is the HTML output obtained from my data topic, which was automatically converted to data from MarkDown. And again, the potential benefits is being able to gather API-related input from developers and single sourcing. Another example is about converting XML schema to data. Maybe some of you do not know what XML schema is. It is an XML language which describes how an XML hierarchy should be structured. For example, right here I have a piece of XML schema which says that the XML element called name should have two possible child elements, family and given, and in any order. So if you have developers who write XML schemas, you might want to look into using this information from the schema directly into your data publication. Because as you see, an XML schema has documentation inside it. So for each element you have documentation. Instead of just pasting the same information in an equivalent data topic, you can obtain the equivalent data topic using this convert sample. So there is only one step to obtain data from an XML schema, and it is made by applying an XSLT processor over the original schema content. Looking back, so we have a schema here. This is the visual way in which a schema looks like. The text representation of the schema looks something like this. So for each element in the schema you have annotation and documentation which can be used in your data topic. And I refer to the schema using the schema to data protocol, and I obtain this data topic, which is the data representation, one of the possible representations in data for this XML schema. For example, the element person has a sequence of child elements, we have links, we have code blocks which give various code fragments obtained from the schema. It is valid data content which we can take and publish, and it looks like this. So from my XML schema, without duplicating content, this example obtained a small data topic containing various pieces of content obtained directly from the schema. So again, this is an example of integrating some format, in this example XML schema, into your DITA-based publication. Java documentation to DITA. We are Java developers, so we write a lot of Java code. Java is a programming language, and Java documentation is a processor which takes Java code and outputs HTML files in a certain format. So if I have an HTML file already created, so this is the HTML file created by the Java documentation for a Java class called button editor. And again, it's not well formed. It doesn't look good at all. I can pass this Java documentation HTML to two stages. The first stage makes XHTML from it, and the second stage applies a style sheet on it called Java documentation to topic XSLT. And here is what the URL looks like. And I open this URL. I obtain the equivalent data topic from it. And then I can, including this data topic in my publication, I can go and see how the output HTML looks like for this. Of course, I can include a CSS which would render this in a more interesting fashion. But how about skipping this stage of passing from Java code to Java documentation and using directly Java code to create a data topic? We have support for plugins in Oxygen, and these plugins have Java API. Let me open one. So this is a Java class. This is how it looks like. For example, it's an interface, and it has documentation for the interface. Each method of the interface is also documented with scenes flag, with documentation for the parameters. If you were to manually create a data topic from it, you would end up copy-pasting content from the documentation in your data topic and then having to maintain that topic each time the documentation changes. Instead, you can apply a two-step processing. First, you take the Java code and generate an XML representation of the Java class. And I did this with a Java processor, which used a special open source library to convert Java to an XML representation. And once you have the XML format, you can apply an XSLT style sheet on it and obtain data content, or maybe other content, maybe content specific to your custom XML vocabulary. Going back, this is how the Java class is referenced in my data map. I open it, and this is the data topic, which is the equivalent of my Java class. Again, read-only. Again, once there are changes in the Java code, this reflects the changes. And then once the topic is included in the data map, this HTML is the result of publishing the data topic. Again, the same benefits, single sourcing being the largest benefit possible. Here is a more interesting example. In this example, we try to take an Excel spreadsheet and create a dynamic image which represents the evolution of a graph described in the spreadsheet, and embed this image in a data topic. And this is done in 2 stages. The Excel is passed to XML using the Excel processor, and then we pass the XML to SVG, which is an XML representation of an image, and we do that using an XSLT processor and by applying a style sheet which takes the data from the XML and generates the SVG. Looking in our data map, so this is a plain data topic and it has the sales evolution graph here, but this is not a static image. Looking at the text content, the image is actually a reference through the conversion protocol to an Excel spreadsheet locating on disk. And the spreadsheet looks like this. So we have a monthly sales evolution with January, February, and so on. And dynamically in the data topic, I get a visual representation of the values from the Excel spreadsheet. So if the monthly sales increase, I can go back and refresh my content, and January just popped up with a larger sales figure. Looking at the published output for this, the topic contains the SVG graph which originated dynamically from the Excel spreadsheet. So you can have graphs which dynamically change in time based on changes made to a third-party format like Excel. And again, you can single source content instead of building the graph as a binary image and having to rework that image every time the spreadsheet changes. That image is constructed automatically from the Excel. And here is a small interesting example which demonstrates two-way conversion, meaning that I have a comma-separated value which has my original content inside it. And this comma-separated value file can come, for example, like an export from a database. And I want to incorporate the changes in a data topic. And I will have two processors. The first processor will wrap the comma-separated value in XML tags, so then I can apply an XSLT processor to it, which is called comma-separated value to data. But I also have a reverse processor. And the job of this reverse processor is to make it possible for me to edit the data topic and when saving to update the comma-separated value on the spot. And my example is located here. Again, a very small comma-separated value with 4 columns, a bunch of numbers and figures and so on. And I want to obtain a data table from it dynamically. So I refer to it as comma-separated value to data, colon slash, and the path to the file. Then if I open my URL, I get the equivalent data topic. And it's a valid data topic which can be used in a publication. And the publication looks like like this. So this is the HTML, the data topic published to HTML format. And what's most important about this is that besides modifying the comma separated value and having the change reflected in my data topic, as a technical writer, I can go ahead and modify my data topic, save, and now I can save because the URL has that reverse processor which is able to convert from this data topic back to the original format. So I save here, go to the comma separated value, and this file has updated. I consider this a very interesting experiment which shows the potential of being able to edit a data topic and have that reflected in another format, in the original format from which the data topic has popped up. So if you have database exports as comma separated values, you can view them as data tables and include them in your existing publications. And also, if you implement reverse processors, in this case we had a reverse processor which was able to interpret the data topic and go back to the comma separated value file and update it when I saved the topic. All the presentation samples I presented today are available on GitHub. We have an Oxygen XML group on GitHub with lots of hobby projects we did using Oxygen and Oxygen's facilities, and this is one of them. So all these samples, the data map, the catalog, all the necessary resources, the style sheets are available in the DITA project together with the README document which shows you how to get started using them with Oxygen 17. I will now give George presenter rights. And, okay. I will remain the presenter, and this data glass. back to you, George.
Yeah, so I just wanted to for Radu to remain to keep the slides on the screen because I can then also look at the questions that we received, and we received a very large number of questions. So before responding to those questions, so everyone can hear them, just a few conclusions. And hope you liked the examples that Radu presented, and that you've seen that basically the data glass seamlessly brings together different formats within a data publication, and he showed a number of different formats published through the Data Open Toolkit as web help, but it can be PDF, EPUB, or any other output format. We think that the idea is quite simple because you just need to refer to a resource through a URL, and with the simplified or short form of that URL, which is resolved through the catalog, that can be only Excel to data or MarkDown to data and so on. But it's quite powerful because then you have full control of multiple processing stages that are applied to that content. And as Radu said, the content is never stored as data, is only seen as data. The actual content remains in the original format, in the target or source format of that document. This is a generic approach. Data is a useful and interesting example. but we can think also, and Radu covered the dynamic graphics in SVG, for instance, from Excel data. You can also think that you can access a web service, for instance, so it doesn't have to be, that information doesn't have to be necessarily in a local file. And all these functionality is already available in the current Oxygen release, version 17. And the sample files and everything that Radu presented, as he showed earlier, is on GitHub in the DITA-based project on github.com/oxygenxml. So I think we can move to the question and answer section. And let me see. Let's take some questions. So a question was, why do people want to move their existing structure content to DITA, right? So content structure in different forms to DITA. Why someone would want to do that? And hopefully, so that this question was the beginning of the presentation. I hope that Radu presented a good number of examples and the benefits at each of those examples. So basically, the main reason will be to reuse the publishing framework that we have for DITA and to be able to include in the same publication content which otherwise would not be available together with the rest of that. So for instance, if you write a user guide for using a library and you have an API documentation, you may want to include a method signature, for instance, and instead of just writing that again, you can just refer to the Java class that contains that method, and whenever that will change, basically your documentation will automatically have the syntax diagram updated with a new signature for that method or a new comment and so on.
And again, the main idea about the presentation is not about moving your existing formats to DITA, is that about reusing your existing formats and seeing them as DITA topics in a larger publication.
Because I also specify that sometimes it's impossible to move to DITA even if you want to, right? Another question was, what sort of things cannot be converted at all? Now, there are, it depends on the degree of structure and that's the main thing, I think, how much structure, irrespective of the actual encoding, is in that in a document. If if you have access to that structure, then you can process that and then you can convert it. So there was a message with someone discovered the location of the DITA class project on GitHub. Radu already included that, but it's http://github.com oxygenxml/dita-class. This could be very interesting for cloud-based documents, document methods like Google Docs or Office 365, allowing content authors to create, contribute, and then have that content as DITA. And the DITA class project already contains a sample conversion from Google Sheets to DITA topics. So basically, you can have people collaborate, edit together on a Google Sheet, and then that will be seen as a data topic in your publication just by pointing to that. That's not a very complex conversion because it's just a chain of 2 XSLT transformations. So if the content is available, processable in some form, then it's easy to be transformed to data. Plus, I forgot, plus an HTML to XHTML normalization of that content. How is the XSL topic ID created? Is there naming control? That was one question, and I think another one was, do you have control over the generated IDs to make conrefs to parts of the converted topic? How do you assure that converted doc gets the same ID after several updates? So basically, the IDs are generated as part of the conversion step. Usually they are generated from an XSLT from the last conversion step, like an XSLT style sheet that you have, and then you can so you have full control of how you generate them, and then the logic that you implement then reflects on how they change when the document changes, right? But again, you have full control over those XSLT conversions because you build, when you define the convert URL, you specify the script, or you can add a last conversion step that just adds IDs.
For example, for Excel to data, the sheet which gets applied to the XML converted from the Excel takes the name of the sheet specified in the Excel and uses it as a topic ID, and the same name is used in the table ID. So if that name stays the same, the table ID stays the same, and you can make the conref and not have it break in another update of the spreadsheet.
Okay, another question was the XSLT. Does the XSL transform tool work with XLSX and XLSM? Probably it's the Excel format in the XML-based Excel format.
The current example I showed was for older Excel style format. You can also use it with newer Excel style format, but you need a couple of Java libraries added to Oxygen in order for the Excel converter to be able to interpret this newer format, but it is possible.
Another question is, are there any limitations or disadvantages? For example, can you lose any content or formatting in a multi-step pipeline for complex input documents? And now, basically, the data class is an architecture, is an idea that allows you to chain together these different conversion steps. What Radu presented are examples of such conversion steps, but it's your responsibility. I mean, you have full control of what you put in these stages, in these conversion stages. And of course, if you put something that will not process the entire content, then that is what you will get at the other end, right?
But that may also be a flexibility, because you can take the original content and with a proper converter style sheet set into place, remove or filter parts from it in order to only display part of the content in the data publication.
You've provided very simple examples. How do you reduce complex information models down to data which generally has fewer data types? Again, all this, the actual logic of the conversion is not necessarily part of the data glass itself. Think of data glass as a platform that allows to bring in your any conversion stages, and you have full control over them. Basically, if you use the Java converter step, you can execute any action. You can execute an external tool, for instance, or and process that content, right? So basically, any uh, um, application that would convert from one content from one format to another can be chained, can be put as one of the steps of the processing steps in the pipeline that is defined by the convert URL. Can I share the link to this webinar recording with my colleagues? I guess CIDM will publish that and it will be freely available. So yes, I'm sure you should be able to share this with your colleagues or with everyone.
You must share it with your colleagues and everyone.
How do the files get compared from source to data to check that all the text has been captured, for example? Is there a way to report the file type of the source other than having to explicit mention of the source format as in the example? So again, the result of the conversion is something that you can test also outside the use of the convert URLs, because for instance, if it's an XSLT step, then you can have a sample input and look at the output of that XSLT step and make sure that it does what you want. So you can test all these stages or these conversion stages outside the convert URL, and then the convert URL just puts them together and makes the conversion live, dynamic, as you use that URL. Another question is, thank you, that sounds very interesting. Will it be part of Oxygen? And another question, will this technology be included in the next version of Oxygen, or it will be available for the current release? And I think Radu already answered that. It is part of Oxygen 17.0, so it's part of the current release. So you can use it right now. And the way to start with this is probably to get the data class project from GitHub, where there are all the samples that Radu presented. Do I have to process my data source using Oxygen, or can I use other tools too? We are moving away from FrameMaker for data content, but all our help systems are generated with the Web Publisher. So this support for these convert URLs is implemented as in Oxygen 17, and WebWorks Publisher will not be able to handle those URLs. What you can do is to include, maybe have a pre-processing stage where you obtain the data XML content and then pass that to a different publishing workflow. It doesn't work directly because we implemented these convert URLs in Java. So any Java tool like the Data Open Toolkit that works with URLs so if the processing is done at the level of URLs, not on local files, right? So then they should be able to work also with convert URLs. Are there any additional modules planned for data glass, specifically modules related to rich text format, Microsoft Word, InDesign, etc., etc.? So I guess we'll develop, further as we get requests or how we see a need for additional conversions. But the Data Glass project is open source, so you can also contribute maybe XSLT style sheets that convert from one format to another, or JavaScript or Java converters and so on. So it's an open source project, and anyone can we welcome any contribution to this project. In the Excel converted to a data table, I saw no column headings. Was that because none were defined, or it is not possible to generate headings from Excel? Do you have any idea, Radu?
Actually, the data topic has headings. Probably the resulting HTML did not contain them because the table was generated with frame none. But this can be changed from the Excel spreadsheet. So we can generate a frame all on the table, and then the table will also have headings in the HTML output. So this is regulated via the XSLT style sheet, which produces the data topic. If the data topic has the proper attributes on it, the table will also have headings, will also have borders, and of course you can have a CSS which matches the first row of the table and displays it in a little bit different manner, so on.
Can you please explain again how the SVG graphic was generated dynamically from the Excel spreadsheet?
So this is the Excel spreadsheet. It has a header, and then for each month it has a number of units which were sold, and so on. It's an old Excel format, but it could be also made to work with the new Excel format. And then we have a plain data topic, just a regular topic manually written, but the image, instead of containing a reference to an SVG file directly, uses the convert protocol to refer to the Excel spreadsheet, to pass it to the Excel converter, which makes XML, and to pass it to this sales XSLT. And this is a sample XSLT which is located here, and it outputs SVG by mapping each element in the XML which was generated from the Excel. And the result is what you saw. The topic obtains the SVG content, and then it gets published to HTML, and it can be dynamically adjusted by modifying the Excel and by refreshing the topic.
How do you reference a subpart of a cross-ref document, or, for example, the third paragraphs of a multi-paragraph document, or a particular part of a large document? So basically, during the conversion step, the conversion pipeline needs to generate IDs for the parts that you want to refer, and then if those parts have IDs, then you can refer that through the data conref support or conref range support. So you can include, from line X to line Y, and so on. Radu, do you want to add something to this?
No, it's okay.
Do your samples include a JavaScript and Java processor, or does Oxygen 17 includes them?
The JavaScript processor is a processor which takes the original content, calls a JavaScript library, which is a set of JavaScript files located somewhere on disk, and can call a certain method from that JavaScript library. And the JavaScript library takes the original string of XML, and then it can produce another string which is the converted content. And we use this trick from MarkDown to DITA. So for this we use the JavaScript processor, which is implemented in Oxygen, but it calls an external JavaScript file located somewhere on disk. It's markdown converter.javascript, and it calls a certain function from it called convertExternal in order to obtain the converted content from the original content.
I assume the processors are implemented as part of Oxygen. Can customers implement custom processors?
Once we have the Java converter available, you can call the Java converter with your own custom Java libraries and request it to call a certain method from a certain Java class. So by the fact that we implemented this Java converter, we made it possible for other people to implement their own conversions based on this converter, to have their own Java libraries which can be called and with a certain interface and can provide converted output from original input.
Will the slides be made available?
The slides are already available on the GitHub project.
I don't think I saw shortdisk in each transform topic. Since shortdisk is a required data tag, how can you include one when using this process? Well, first of all, shortdisk is not a required data tag; it's an optional. Only a title basically is required in a data topic, and the shortdisk can be generated as part of the conversion process, right? So basically, it depends on the conversion steps that you have.
But you can also have another data topic which has a title and a short descriptions and makes a content reference to just a part of the converted content.
Then terminology can be important. You should use scheme, not protocol, and these are, we are talking about URIs, not URLs. Well, basically we use the Java URL support, which is pluggable, so you can bring in your own URL implementations. Yeah. How you will ensure interoperability of your pipelines URIs, given that you have not any formal registration of your novel schemes. Well, basically, the convert URLs are just a way to bring together different transformation chains, different transformation stages. DataGlass is a proof of concept in the end, showing that URLs can be used for to encode this type of conversion to make it dynamic, to make it work at the moment you read that information. Now all the processing is basically defined in the URL syntax. So as long as you use that and you apply those processing, you should get the same results. Can DITA Glass work with other tools, such as conversion from XML to InDesign? Well, if you want to use these convert URLs from within InDesign, I don't think that will work. But this type of URLs, as we implemented them, can be used on the Java platform, because, as I said, the Java platform has a pluggable support for registering a URI scheme. So then you can use them in a Java application. Of course, the idea of using URLs to encode this processing, these conversions, and have them dynamic will allow people to implement such URLs also in design. I mean, if you open a web browser like Chrome and you go, or Firefox, and you go to the settings, you will see that it's a URL displayed in the URL in the address bar that says something like Chrome column/settings or something like that. So that's also in a way a custom URL. They are not reserved only to Java. Do all content authors need to upgrade from 16.1 to 17, or can just the information architect upgrade to take advantage of DITA Glass? In other words, is the process backwards compatible? Well, if the authors will have a file that refers to a convert URL, that will not work. It will be like a missing resource on 16.1.
Yeah, so they can go ahead and ignore that missing resource warning and expect that the published output will still contain the proper information. And
what is the sample URL? I guess this refers to the DITA Glass project, I guess. So maybe Radu, you can show again the URL on GitHub, the GitHub URL. Can DITA Glass be used to convert InDesign to DITA? We do not have a pipeline or a processor to do that conversion, but as long as that you have already existing code that can convert InDesign to DITA, you can put that as a convert URL and use it. URLs can locate local files. I guess that can URLs locate local files? Well, the convert URL will, being a different scheme, will not allow you to have a local reference to the current topic, because the current topic may be accessed as a file URL, and a relative reference should be also a file URL. But what you can use, and Radu showed in one of the slides, is you can define a URN in the catalog and resolve that to a folder, for instance, and then you can use that like URN column files, and then point to a file relative to that folder that is defined in the catalog as resolving that URN to. Will you maintain a registry of well-known conversions? Well, we haven't thought of that. It may be an interesting idea, but we haven't thought of this. Not sure if this has been asked. we have many input data. Most are XML and comma separated values. Is there an easier way to convert data to DITA other than writing lots of XSLT? Well, for comma separated values to DITA, Radu already presented that DITA class has a sample. Actually, it's not something we developed. There is an XSLT already available. I think you can find the attribution information in that file in the DITA class project. So it's but yeah, if you have XML and you want that to be converted to DITA, the most probable way to do that would be to write XSLT, or the most easier way to do that will be to write XSLT. Can I use these Java libraries from a Unix command line, for example, to convert an Excel file to a DITA file? Well, while this can be moved completely outside Oxygen, it was easier for us to implement these conversion steps within Oxygen, because for instance, for the XSLT converter, processor that can be triggered within the convert URL, we use Saxon as the XSLT processor, and in Oxygen it was already set with available also with the professional edition or enterprise edition level. If we move that outside Oxygen, then we had to do a lot of setup, make sure we use only no extensions, so home edition level and so on. But the idea can be implemented by anyone, purely on Java, just by registering the convert, or you can call it also, use a different scheme and xconvert or whatever, and define your own syntax for that, and then you could use the same idea and make an implementation for a conversion also outside Oxygen. I think we managed to go through all the questions. I see that many of you are still with us, so thank you for joining us today. And yeah, it will be interesting to see how this will develop further. Radu, do you want to say a few words? Thank you, or before we get control to Loponia?
Thanks for joining us, and I hope you liked what you saw, and I hope you'll get many more ideas than the samples I just showed you, because you have probably more interesting use cases that we thought of. And what can I say? Thanks again, and have a nice day.
So thank you, Loponia. You should take control for final words.